magnet versus slime mixed with iron sand. We note that the iron sand is attracted by a magnet. Let's see what happens if we mix iron sand with slime. It moves upward like a snake. Magnet versus iron sand. We place a magnet on a table and place small glass plate on top of it. By adding iron sand in a plate, we get spikes-like structure.
Magnet versus iron filling water.
Pour water in a jar and then add iron filling in it and cover it with a cap and mix it. Now putting magnet closer to the bottle, you can see that the iron filling make a structure to that side, which look very interesting to look at. Magnet versus ferrofluid. Take a bowl and put a large amount of salt in it. Now take a beaker with water in it and mix salt in it. Put that salty water in a bottle and add ferrofluid in it. It makes black bubble which is attracted by magnet.
Magnet versus bolt and ferrofluid.
Take a magnet and put bolt on it and drop ferrofluid in it, spikes-like structure will be produced.
Magnet versus printer ink and oil.
Take a
magnet versus matchsticks.
And now we put some matchsticks in a plate and we can see that it does not attract with the magnet. Then we see that when we place magnet near the burnt matchsticks, they get attracted to the magnet due to the reaction of iron oxide and carbon when matchsticks are burnt.
Magnet versus heat.
This is a heat reaction. If we heat a magnet, it affects the magnets because it confuses the magnetic domains, causing magnetism to decrease. Take that they are balanced really well and they are standing vertical due to the magnetic attraction above them. Same is the case with this one. We placed two magnet bars on one another with a stick separating them and then attached coins below the magnetic bars. There is a magnet placed below also. So if we stick the coins to that magnet, the coin still maintains their shape due to the high magnetic attraction.
Magnet versus homopolar effect.
Take a battery and join magnet on it. Magnet versus electricity. Take a cylinder-like object and roll a copper wire on it to make rings-like structure. Now put the battery on the magnets and place a copper ring on it to start rotation due to the Lorentz force. Magnet versus batteries and copper spring. In this experiment, placing magnets in both directions of the battery and putting that battery inside of the copper spring, it starts moving in spring due to the attraction force and homopolar effect. Magnet versus current. Take a wire and fold it like this with two endpoints. Now attach the magnet with battery and safety pins on both sides of the battery. Now put the wire in it and you see rotation of the wire due to magnetic field.
Magnet versus fluid viscosity.
Take oil. Magnet versus life hack. It is impossible to clean the inside of the bottle, but if we cut the sponge into two pieces and put two magnets in the sponge by glue, now put one magnet sponge inside the bottle and see it works.
Magnet versus Levitron.
There are two main properties that allow the Levitron to levitate stably. The first is the magnetic repulsion, which provides the force for levitation. The second is gyroscopic effects due to the spinning of the top, which accounts for the stability of the levitation. The levitron consists of base and a top. The base is a ring magnet with north oriented upwards. The top is a magnet with north oriented downwards. The two nodes repel, thereby providing an upward force on the top due to the magnetic field from the base. For more videos like this, please subscribe to our channel.